10.1, graphs and models. A graph consists of V, which is a non-empty set of vertices, also known as nodes, and a set of edges. Each edge has either one or two vertices associated with it, called its endpoints. An edge is set to connect to endpoints. So we can do an example. Suppose we have a network is made up of data centers and communication links between computers. And we can represent the location of each data center by a point and each communications link by a line segment. The computer network can be modeled using a graph in which the vertices of the graph represent the data centers and the edges represent the communication links. So let's do an example of it. So this vertice right here could be a location, like San Francisco. Spelt that wrong. San Francisco. And it's connected to another vertice, which we can label as Denver. And this connection is done via the edge, or the link between them. And then we could further have another location called Los Angeles. And this vertice can be connected to Denver via another edge. And San Francisco can be connected to Los Angeles via another edge. So these points are known as vertices. And the line segments joining them are known as edges. So this is a simple graph that we're looking at. So notice that each edge of this graph connects two different vertices. So a graph in which each edge connects two different vertices and where no two edges connect the same pair of vertices is called a simple graph. So this can be known as a simple graph. And a computer network may contain multiple links between data centers. To model a network like this, we need graphs that have more than one edge connecting the same pair of vertices. Graphs that have multiple edges connecting the same vertices are called multigraphs, and I'll show you what it looks like. So say we have same locations, San Francisco, connected to a data center in Denver via the same link, and we have a data center in Los Angeles. And they're all connected via edges. Now, what if there is more than one connection to the data center? So there can be another connection from LA to Denver to the same data center. And graphs that have multiple edges like this are called multigraphs. So far we have learned that we have simple graphs, which contain one edge between two pairs of vertices. And we have multigraphs, which can have multiple edges between two vertices. Now, there is another type of graph that we're about to learn called pseudographs. What is a pseudograph? A pseudograph is a graph that can contain loops. So let's do another example of what a pseudograph would look like. So we have our location in LA. We have our location in San Francisco. And we have our location in Denver. And they're all connected via an edge. And so far, this is a simple graph. To turn it into a multi-graph, we would simply have another edge that connects between LA to San Francisco, and there could be multiple of these. Now, what if there is a data line that goes from San Francisco back to itself? This would be considered a loop. And when we have loops in our graph, they're going to be known as a pseudograph. And so far, all the graphs that we have talked about, a pseudograph, a multigraph, and a symbol graph, are all undirected. Now, what is a direct graph? A directed graph is as follows. So it consists, again, non-empty set of vertices and I'm going to denote vertices by capital V, and a set of directed edges. And each directed edge, denoted by DE, is associated with an ordered pair of vertices. And the directed edge associated with the directed edge associated with the ordered pair UV is set to start at U, so starts, and ends at V. And when we have a directed edge that has no multiple edges or loops, it's called a simple directed graph. Let's take a look at what that looks like. So a simple directed graph would be as follows. We have San Francisco. We have Denver. And we have LA. Now we have a communication line that goes to LA from San Francisco. And this is how we would denote it. Similarly, from LA to Denver, we could denote it by an arrow showing that this directed graph is growing from LA to Denver and from Denver to San Francisco. This would be a simple directed graph. Now we can have a multiple directed graph. So if we were to copy this, if I just pasted it here, demonstrate a multi-directed graph, you would just have multiple edges. So you can say it's going from LA to San Francisco. This would be an example of a multiple directed edge graph. And there's another type of graph that we're going to go over. For some models, we may need a graph where some edges are undirected. And if that's the case, and we have some cases with undirected graphs, undirected edges, like this right here, which is undirected, this graph would be called a mixed graph. So let's go over the type of graphs that we have learned about. Let's take a look at the type of graphs that we've learned today. So we have simple graphs. So we can look at the type. The edges are going to be undirected, so I'll denote it by UD. Can they have multiple edges? And do we allow loops? Well, for a simple graph, we cannot have any multiple edges, cannot have loops. What about a multigraph? The edges are going to be undirected. We can have multiple edges, but we wouldn't have loops in a multigraph. What about a pseudograph? The edges will be undirected. We can have multiple edges, and we can allow loops. What about a simple directed graph? The edges are going to be directed. We will not have multiple edges, and we will not have loops. What about a directed graph? A directed multigraph. The edges will be directed. We can have multiple edges, and we will have loops as well. What about a mixed graph? The edges can be both directed and undirected. We can have multiple edges, and we can have loops as well. So these are the different types of graphs that we went over today.